What's up, guys? Back with some more practice with functions today. The first video that we did, about a 12-minute video, was really informational, right? I had to give you guys a lot of information. If you need a refresher on what that stuff is, please watch that video again. It's good information there. Today's going to be a little bit more interactive. I'm going to ask that you guys try to solve these problems that I'm going to present in the video, right? A great way to learn this stuff is get it wrong, right? Try something, right? At least you're being a part of this education, okay? So let's go ahead and we're going to start off with two tables here. And what I want you to do is try to write the rule or the equation that goes with these tables, like we practiced in the last lesson. And we're going to be doing this a little bit more today. So go ahead and pause the video right now. Try to write the equation for both of these functions here. What is the rule for these functions? Okay. All right, here we go. Let's take a look and see what you wrote down for these. Just briefly and quickly, I'm just going to write what I think the rule is. Like if I look at these numbers on the top row, the inputs, and I look at my outputs, what's happening to the input that gives me my output down here? I have a 0, 0, 1, 3, 2, 6, 3, 9, 4, 12. And I think to myself, well, what is happening? Could it be addition? Could I be adding 2, right? 1 plus 2 is 3, so it could be plus 2. But 2 plus 2 is not 6, so that can't be the rule. So then after maybe some trial, you see that I'm taking the first number and multiplying it by 3. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. So the rule is to multiply by 3, right? You multiply 3 times the input, 3x. Just 3 times whatever this x value is up here gives me the y value. And the way we write that equation is, remember, the output y is equal to 3 times the input. Just 3 times the first number. So we say y equals 3x. Now let's take a look at this one down here. Again, we start off with the 0, 0. So we know it's not addition or subtraction because if it was addition or subtraction, then this would change, right? But it doesn't. 1 to 9, 2 to 18, 3 to 27, 4 to 36. Again, we're increasing from the input to the output. And this is another multiplication, right? What's happening to the input here is that it's being multiplied by 9. So we do, the rule is 9 times x, 9 times the input. So what does that equation look like then? Well, y, the output, is equal to 9 times the input, 9 times x, y equals 9x. Okay? And if we were given a number, no matter what that number is, we could figure out what the output would be. For example, if I said that the input was 10, right, if this graph kept going, and I said that the input was 10, you could probably tell me what the output would be, right? If the input was 10, then we just multiply that by 9, and the output would be 90, right? So there's our rules. A little bit of practice there. Today, we're going to focus a little bit more on that problem. Today, we're going to focus a little bit more on how to take it from words and put it into that a function rule, right, or an equation. And it doesn't necessarily have to be x and y, because the stuff that we're talking about could use different variables based on what we're talking about. For example, a runner's distance in a marathon is equal to 8 miles per hour times the number of hours, right? So what we need then do is we create an equation based on that. It says that the runner's distance, right, d, which we don't know what his distance is in the marathon, is equal to, that's a dead giveaway, that's an equal sign. So his distance is equal to 8 miles times the number of hours, right? So you're using 8 miles per hour. So 8 miles in 1 hour, 16 miles in 2 hours, 24 miles in 3 hours. So like you could imagine the table might look something like this for the time and distance. The table could look something like, well, if he goes for 1 hour, that's 8 miles. If he goes for 2 hours, that's 16. 3 hours, that's 24. 4 hours is 32, right? And so on and so forth, right? So our equation then would just be the distance is equal to 8 times the number of hours, t, which represent the hours there. So, but our job is to see if we can go from just the words here to this right here without necessarily having to use a table. And you could use a table if you want to. But go ahead, pause the video here, and see if you can write the equation for this problem. A mouse can travel 8 miles per hour. write an equation to find the total distance a mouse can travel in h hours, however many hours it goes. All right, and let's see what you got. This is very similar to our last problem. Instead of a runner, we got a mouse. And the mouse can go 8 miles per hour, that's freaking impressive. If a human being can go 8 miles an hour, imagine a mouse doing it, right? So what we have here is this whole problem is based on not how far the mouse goes. The whole problem is based on how many hours is the mouse going to be moving. And that's what the input is. That's what's going to be combined with this 8 here. So the mouse's distance is based on 8 times the number of hours it goes. Right? If it goes 1 hour, that's 8. 2 hours is 16. 3 hours is 30 or 24. And this is all going to give us the distance the mouse travels. D equals 8h. You could also technically write this as 8h equals D, but in functions we normally put the output first. Kind of weird. Try this one, please. Samantha can make 36 cookies each hour. Write an equation to find the total number of cookies that she can make in h hours. Okay, we'll see what you got. 36 cookies each hour. This problem is based on how many hours she's making cookies. So I know that's my input. She could make cookies for 1 hour. She can make cookies for 2 hours, 3 hours, 4 hours. So that's going to be my input, right? So if I'm thinking in my brain here, I'm thinking 1 hour, 2 hours, 3 hours, 4 hours. The question is, how many cookies would she make in that time? How many cookies would she make in 1 hour? Well, 36. How many cookies in 2 hours? 72. How many cookies in 3 hours? 108, so on and so forth, right? So what's happening here is we're multiplying the number of hours times 36, 3 times 36, 3 times 36. So then the function here, the rule, is the number of cookies that she can make is based on making 36 of them per hour. 36 times the number of hours will give us how many cookies she's making. C equals 36H. Now, ultimately, what we're trying to do here is, and I told you this in the last video, that we are going to be trying to take this from a word problem and end up on a graph. Right? We want to be able to represent this information on the graph. So here we go. What this looks like all together. While in normal flight, a bald eagle flies at an average speed of 30 miles per hour. Okay, so what we're going to do is we're going to write an equation and make a function table to show the relationship between the distance and the hours. For example, on the table over here, if the bald eagle, and you can choose whatever numbers you want for these guys, but please, 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 just use easy numbers. There's no reason to put like, let's pretend that the bald eagle flies 50 hours. That's crazy. Okay, it'll work. You could give me the answer, but you're just going to shoot yourself in the foot on that one. So let's just say the bald eagle flies for 1 hour, right? 2 hours and 3 hours. Nice, easy numbers to work with. If the bald eagle flies for 1 hour, how many miles would he go? Well, he's going 30 miles per hour, so that's 30 miles in 1 hour. How many would he go in 2 hours? Well, 2 times 30 is 60, and 3 times 30 is 90. It would look something like this. Now, the equation for this would be the bald eagle's distance, right? The output is equal to 30 times h. That's the function we were doing, right? That's the rule that we have here. 30 times the number of hours gives us the distance. And that shows the relationship between them. The next thing we do is we take these pieces of information and create a graph out of it. So each input is the x value, right? If we remember that ordered pair is x, y, each input is x and the output is y. So our inputs and outputs would look like this. The first one would be 130. The next one will be 260. And the last one would be 390. Okay? So what we'd then do is take these inputs and put them on a graph and see what it looks like to show the relationship on a graph. So the first one is 130, so we go to 1 over 1 up 30. Then we go over 2 up 60. Then we go over 3 up 90. And our graph looks something like that. And that's kind of the culmination of functions, guys, but it's just really good to get good at turning this into an equation, into a table, into a graph. Good luck on today's assignment. Let me know if you have any questions.